what else? You should go through all the workflows and data flows. What they are is basically where this flag of operation is moving. Yeah, so how this schema of application execution looks like, and how data is passed through these different steps of application. What you need to identify here, the most importantly, is where the data that you provide is then used. Okay, so this will first of all let you guess the attack entry points, yeah, because only the data that could be, when smuggled into the application, used maliciously, yeah, somehow with some untraditional intent, yeah, is important to you. It's not important what any other things you provide to the application do. Yeah, to prioritize your effort, you could do that first of all. And in terms of business logic verification, you have to understand how the data you provide controls the routing of that workflow throughout the application logic. And of course, review of controls. So you should see where these security functions are implemented, and then after that, focus on testing whether they are efficient and effective. What you should ask you all the time when going through this business logic review is two things. Yeah, so remember that developers, then they construct that web application, they are normally asking themselves questions: what happens if that condition holds true or not? Yeah, so their logic is quite conditional. They are thinking positively. So what happens if this situation arises? Yeah, so if we find ourselves in this particular situation, what are our actions? Yeah, so that's more realistic approach to life. What happens if? And then they make some assumptions. So if that happens, we do that, and that. And what you should ask yourself, yeah, when you are reviewing the same situation is: what happens if not? Yeah, what happens if somehow this situation, yeah, this artificial situation they are processing right now in this particular point in application workflow is somehow tweaked. Yeah, so they assume that the traffic will be generated by browsers and sent to web servers. What if not? Okay, what if someone is putting an intercepting proxy in between and capturing all the requests, modifying them slightly, and then sending through to the web server, right? So challenging the assumptions that the web developers have made when created the software is the main task of finding of penetration testers, trying to find business logic flaws, yeah, wrong decisions made throughout business analysis, design, architecture, and implementation of the software. What if it works this way, but what if not? Highlights of risk points that could result in business logic flaws are pretty much the same, yeah, as before, but maybe in a slightly different form, yeah, under some other angle of view, from other point of view. So of course, data validation is key. Okay, if something is passed to the web application's internals without properly validating against some criteria, like filtering the escape characters or filtering some gibberish, yeah, that's wrong. Yeah, that can result in us taking control over the web application. The extreme point, of course, is just comparing the input to some limited choices. In that case, there is not much we can do in order to circumvent data validation. But normally the data that is expected by the web application is more or less deliberate. So users are free to input different strings or numbers, and then some type validation and length validation begins. So all that should be reviewed by us in order to find specific errors or flaws in implementation or design. Request forgery. So if we can trigger some unexpected behavior of legitimate users, yeah. So if we can trick the admin to run our specifically crafted requests, what happens then? Integrity checks of data passed through, yeah, and the sessions mechanism, yeah. So every time we can tamper with the web server's presumption, yeah, of what's going on in legitimate sessions on a legitimate network connection, if we can intervene there and change slightly or dramatically what's going on, yeah, we can start manipulating the web server behavior from there, and basically that can lead to complete compromise. So if somehow we can, for example, just substitute those web tokens, yeah, Java web tokens. One time, at one moment, we are just merely legitimate users, and if we are guessing what's going on in the integrity checking mechanism and can somehow guess the key that is used for signing the token, we can just remove one role and put another role there and assign ourselves admin privileges and perfectly sign the token and get elevated permissions in that way. Process timing and rate limits. So process timing is quite tricky, and in web applications it's maybe not that critical as in offline cryptography functions or hardware cryptography or something like that, but still it has its effect, of course, because by just measuring the time that passes when we provide the web application with different input data can give us an idea of what's going on, right? So, for example, if we are doing some password guessing and we are not sure about the login names, yeah, so we just are not aware of like an explicit list of possible usernames on that web application. But if we see that with the same password, some logins are taking much faster to process, okay, some login attempts with particular login names are much faster, we can infer that yeah, that is a valid login name, yeah, because it's 10 times faster than another one that is just gibberish or presumably not in the user database. Okay, so this this functionality could result in us successfully guessing at least the usernames, which is half of the job for password guessing. Okay, what is the rate limits is of course for logins it's very important, because if we are not limiting the amount of API calls or web application requests that we get from a particular source, we are not doomed, but the successful attack on the web application is just a matter of time. So each time you see that you can repeatedly and successfully make attempts to perform some actions, yeah, that can be a red flag and the reason to investigate further and see what actually you could do with that. So if you are not limited in speed of interaction with the application, that can help you hack into it more quickly or more effectively. So What could be an example? So let's say you have a really large application that is configured by some specific metadata, and each user is like jailed maybe to a particular flavor of environment. Yeah, so I don't know, maybe you have different locations and every user is operating within a specific location, like a country or a town. Yeah, so let's say all those locations have specific code names. So you do not put the name of location into the request. You just put the code, and the specific codes of those locations are somewhat sensitive, because even by presenting those locations you can like reconfigure your session, and you are not supposed to do that. Yeah, a legitimate user has to be like within some specific location for that matter. And if you don't limit the rate limits, yeah, you could cause this possibility to just flood your application with different values, to fuzz your application with different values, and seeing what happens. And if some difference, if there is some difference between just a complete nonsense provided or and some reasonable value of that location code, the attacker will see that and will collect only those codes that are reasonable, and then mount some other types of attacks. So maybe it's not really harmful at this point, but it will definitely supply useful information for further attacks by the perpetrator. Circumvention of workflows, I have already given a few examples of that. So going right past the login screen, yeah, is one of them. On the mobile applications for Android, for example, it's really popular to just attempt running the application not from the default main activity that is normally just a login screen, yeah, asking you for a login and password, but trying to request another activity that is logically going after you successfully log into the to the mobile application. Yeah, the same thing is true for API calls and web pages. Why trying to successfully log in if we can try just going directly to the things that are important to us and matter in the web application, okay, and check whether there is some access control at all. And file uploads. Oh, file uploads is a very interesting topic, and if you have time, please review that, because you can find it really interesting in many ways, because the files that you can upload to modern web applications are quite diverse in nature. So this could be like document files or image files, and even just staying with image files, there are different types of image formats. There are just compressed image formats, or there are vector image formats that are basically just XMLs that can be that can contain JavaScript code. Yeah, so XXC vulnerabilities in SVG graphics are like really popular right now, you know. So that's really funny how much you can force from the web application, how much potential you can have attacking a web application just by being able to upload deliberate file formats to it. Okay, so there are different attacks, and of course you can even try to upload some executable formats, like some malware files. Not malware in your particular case, since the hacking you do is ethical and you have users consent over it, but still, so just trying to smuggle some executable file to the web application, and trying to guess what then happens when web application processes it, whether it runs it or just parses it, and so on. That's really an interesting topic, which is kind of out of scope of this video tutorials, but I will give you directions in the references section on what and where to search for in order to know more, because it's quite diverse and really interesting and quite funny sometimes.